Hello everyone, welcome to the last packet tracer activity in this course, which is under 6.3.2.3, which is about a case study about how or a prototype and test the solution using packet tracer. And here we will have a complete example about a garage door or anything in your home or in a home. Then we are going to learn how to connect this traditional, not a smart door, to an internet. So to do this we need a Raspberry Pi to connect this traditional door to an internet, and then we need to write a program here, and then we can control this through the home or through out of the home. For example, here when this example, like in this prototype, we have this door connected to the internet through the cloud. There is a cloud here to collect the data from this Raspberry Pi about the door, and then the user can access this data or this the program or control the door from out of the home. So there is no need to be inside the home. Let's assume that he went out at one of his friends, and then he wants to check that the door is open or open or close the door from out of the home on another city. Only there is a need to connect to the internet. The data can be collected in the server, which is the cloud server here, as you can see, and this is the internet, and any device with an internet connection can access to this data or to this program and control the door. However, we will see the things in a couple of minutes. Okay, so here we need the scenario. As you can see here, you will have a chance to explore packet tracer based IoT system prototype designed to allow a user to remotely check whether the garage door is open. You are encouraged to freely explore the prototype and gain better understanding of the topology used in this system. Alright, I'm using packet tracer 7.3 as you already know. Here is the scenario, or here is the situation. As I mentioned at the beginning, there is a traditional door. We need to connect it to the internet, we need to control it, so this is why we need to Raspberry Pi, and this is SPC here, and then we wrote a program here, and then we will see. Okay, so actually the program is already written by the task. Okay, so what we can see inside this topology, there is also inside this home, there is a PC home and there is a laptop home. So this zone here, that this is including inside the home in the same wireless router which is inside this house. There is another router to access the internet which is in another city, let's assume, on another place. Okay, so and this home is connected to the internet using this DSL modem. Okay, and now let's try to see how this door is connected or controlled through Raspberry Pi. So as you can see here, there is a program here, and let's try to analyze the program. Here we are imported three modules, the TCP module on the time and GPIO for the Raspberry Pi. Here we have a variable called TCP client, and then we have another variable for G1 equals 0. And then we connect it to the input pin number 0, you know this is the pin, and then we put the value of this pin into G1, the variable we just defined, and then we define an IP address of the server with the port number. Alright, then we define a function on TCP connection change, and then if there is some, like, we print the type of this connection, the connecting changed, and then we print this type here, and then we define on TCP received there is a data, we print also the data, and then we type click send of the data. Alright, or sorry, client send all the data, and then we define the main function, and then we call from the client on connection change, and then we send this as a parameter, and on receive we send this as a parameter, and the type is here, this one. Okay, so here as you can see, this one is going to be this one here, and also for the data is going to be on TCP receive. Then we print the server ID and the port number. Okay, then we go through the infinite loop, as you know. Then we call, we read, and we check. So, and then we delay, we have 1000 milliseconds, and then, you know, these two lines. All right. So this is the program here. Let's now try to answer the questions. Click the Run button to execute the program. What happens? As you can see, there is what is happening. And as you can see, current door status is 0. It's closed. Let's try to open it. As you can see now, the door is 1. Okay. How often are the door status updated? Updates sent to the internet? As you can see here, it's written somewhere there is a delay, which is 1000 millisecond, or it's 1 second. So the status of this door is going to be changed each 1 second, or actually not changed, checked, to be more precise. So if I'm going now, the door will not close automatically. There is no such thing in the program. We only need to close it or open it by ourselves. So now I'm going to press Alt on the keyboard and click on this. I close the door and now it returns to 0. So it's not going to be automatically open. Okay, what is the IP address and the port number of the server and the internet? This is the IP address and this is the port number. Now be careful, this is the server IP address which is in the cloud. So if you have a tool that you need to connect to the cloud, then you don't need to buy a server. Actually, you need to buy a service from the server, and for this reason you can use any cloud services. For example, Amazon Web Services. You can buy like a small domain for your name, or then you can use it for like for your application. So if you go here, and now you can see server PT DNS. This is the cloud, and as you can here, for example, let's check here. So here 209, 165, 200, this is the DNS server. This is the default gateway, and there is the DNS server. So as you can see here, as you can see now, there is the IP address here. Okay, here we can see that there is HTTP server. Okay, here is also the application of the server for collecting the data from the home. So here we have, this is the web server that is connecting to this Raspberry Pi, and then we send and receive. So the connection between this Raspberry Pi and this one, the server on the cloud. One more time, you don't need to put a server on the cloud. You can use any web services or cloud web services. All right. Okay, hopefully it's clear. So what are the variables name used to store the IP address and the port number? Here you can see this is the server IP and server port. This is the port and this is the IP address, and why Python modules were important, or what Python modules were imported into the code. These three. Okay. One more time, let me repeat the concept. The concept is that we have a server in the cloud, and then we have a subscription to this server. We can use part of it, and then we send in our program, we have a connection to this server on the cloud. One more thing, we also have to know about this DNS server. When, of course, since we are talking about the internet or cloud, so we have to know the concept of the domain name system. All right, now let's try to use the system, and here we have the IP address for this server, which is connecting example, or you can put the IP address of the server from the internet. Let's copy this, and now let's check the IP address of actually this one, which we can get it from the DNS server. So if we can go here and we go to services and then we go to DNS, we can find here the IP address of this web service or web server. So the name of this server is this one, and the IP address of it is this one here, 209.165.200.1.2, which is the IP address we wrote it here, if you remember, in this program here. So we connect to the server. Of course, as you know, when we use HTTP, we type the URL, but actually there is a DNS server somewhere. This DNS server has a database to specify the IP address of this server is actually this one here. Okay, so hopefully it's clear. Going, and then let's go to the desktop and then use this by here. And we have this now here, the garage door is shut as it's written here. And then what is the status page still open in the smartphone? Open the garage door. Okay, so let's do this. Alt and click. Here we should see that now it's open. What the display in the smartphone, now we can see now that this red. Based on what you have learned in this course, what would the rule of the internet server used in this packet tracer prototype? Here we have like that we have an internet cloud server, this one here, and then this server providing the cloud like an internet cloud server. So we can only, so the server here collects the data from there and can be accessed from everywhere in the internet since it's in the cloud. Here also the system is designed to allow any user, any device to connect to the internet. Try to open a door status page from the home. Okay, let's do this. Let's go to the laptop here, desktop, then let's type here. It takes a bit time, but we should see the page here again. As you can see now, the door is open. Let me close it. Now, as you can see, it's green again. What is the benefit of accessing the system from within the house? Of course, you can control. So, for example, if you are close to the home, then you will need to open it, or you are in the kitchen or in bed, so you can control also the garage or the door of the garage door. Okay, so here we have a challenging questions. Expand the internet cloud and explore the content. Try to locate DNS server and try the web server. I already showed that. Locate the multi-layer switch. What is the function of this prototype? Let's try. What is the function of this prototype? Actually, it could be useful or it can be used as the main router to entire topology. So it connects the server and the cloud and the DNS server and the web server. Actually, they connected together to the cloud. And also we have here add more devices to the home network and try to access them from there. So of course you can do this. The system currently doesn't store the door status, but it could be a good idea for future. Can you think of one benefit of storing the door status over time. So actually you can have a log file when when it was open, when it was closed, who opened it, which IP address. So you will have more statistics about this status of the door. Can you describe or an overview what changes you have to happen, like would have to happen for the current system to track the status? Well, actually, we can when we change the status of the door, we save the old value in a file and explore it always in the file like a log file, and then we check the file frequently. What crucial IoT feature is missing from this prototype? It's security is always the big question, of course. Okay, so as a reflection here and as a summary of what you have learned from this course is that the system here as in Packet Tracer is about showing you the concept, how can you build and test the devices or your IoT solution before deploying it to the real environment. So you can check your program, you can check the software or the application or the web page you have designed. A packet tracer Python support makes it easy to improve and eventually port any code to an actual devices when the test phase is complete. So when everything is done, it's okay with the packet tracer, then you can move to the real environment. With this task, I would like to thank you for your attention and enjoy and have fun with Internet of Things. Bye bye.